Hello, welcome to Starry Skies on Forest FM. This is our new magazine that we're going to do every month, covering the stars and planets and all the other objects that we can see in our East Dorset skies over the next 30 days or so. This is Mark.
And I'm Steve.
And we're local astronomers living here in the region. And we'd like to talk today about the sun, the moon and the planets that you can see during March. Some special objects that will stand out, such as the recent green comet, a constellation of the month and how to find it, and any other unusual objects that we may be able to see this month. So that's the plan.
Okay, so where are we going to start, Mark?
You know, the good old green comet's gone, hasn't it, Steve?
Oh, yes. Oh, why did they call it the green comet? It's because C 2022 E3 bracket ZTF close bracket really does not trip off the tongue.
It didn't, did it?
And all comets are green if you photograph them, so, hey,
Yeah.
what's unusual about that?
And it's just going away from us. It didn't flash through the night sky, did it? As said in the media, not at all. We saw it for several months.
Yeah. No, I've been watching it for 2 months now. I mean, it's now I can only see it in quite large binoculars, but it was the sort of thing that when it was at its peak round about the beginning of last month in February, it was absolutely lovely. You could just make it out with the naked eye, but binoculars really pulled it out. What people did expect to see, and which they didn't see, was its tail. And the reason for that is the tail was going away from us. So the tail was in line with the comet. So we weren't looking at it edge on, we were looking at it head on. But so things are sometimes not what they seem.
And we don't know whether there'll be another comet this month or next month because, as we all know, they're very, very unpredictable. And who would have known that this one was going to come along? It hasn't been seen for 50,000 years, I think, and it won't be back for another, will it?
It won't. As the great comet watcher David Levy, if you may remember the comet Shoemaker-Levy that ploughed into
That's the one, yeah. Jupiter,
yeah. What David Levy says about comets, he says they're like cats. They have tails and they do whatever they like.
Exactly. However, we can still just about see it during the month of March. Comet ZTF, or the Green Comet, is still just about visible in binoculars if you know where to look for it.
Indeed.
In the constellation of Orion, and moving towards the end of the month further and further south and less easy to see, fainter and fainter as it disappears out back to the very, very outer edges of the solar system.
Yeah, so let's come back to the beginning of the month. We start off with something absolutely cracking.
Yeah, really great.
If you look into the western sky just as the sun's gone down, you'll see two very, very bright starlight objects. In fact, they're not stars, they're planets. And they are the planets Venus, which is the brighter one, and Jupiter. And on the 1st of March, they are going to be so very, very close in the sky.
How close, Steve?
So close that if you put two fingers up in front of you and hold them at arm's length, it will cover both of them.
Right. And they are the two brightest objects in the sky, apart from the sun and the moon?
They are indeed. In fact, photographically, Venus is actually brighter than the moon. It's 2 stops brighter than the moon.
Wow. And which is the nearest to us? When we look at them so close in the sky, which is actually the nearest planet to us of those two?
Oh, Venus.
Ah, right. Why is that then?
Because Venus is between us and the sun, and Jupiter is many, many times further away from the sun than we are. But Jupiter's the biggest planet. It's 11 and a bit times the diameter of the Earth, and it contains more matter than the rest of the planets in the solar system. It's more than 2.5 times the mass of all the other planets put together.
Whereas Venus is more or less a sister planet to the Earth. It's about the same size as we are.
Indeed.
It's a little bit closer to the sun than we are, but you don't want to go there, do you?
You do not. Because
Absolutely
although
not.
Venus is the goddess of love,
the atmosphere will not, you will not love it at all. It's
but
very hot.
The thing we need to remember is Venus in mythology, Venus, Aphrodite, the goddess of love and the goddess of war as well. It's the passion of both of them.
Absolutely.
And Venus is more like the traditional idea of hell.
So what about the other planets in the month of March then, Steve? What else we've got? We've got Mercury's nearest to the sun. Can we see Mercury this month? I think it's actually a little bit near to the sun.
Mercury stays very close to the sun, so we hardly ever see it. But what we can see is Mars,
Yeah.
Mars looks like a very, very bright orange star. It's not bright red, it's more a sort of rusty red colour. And the time to see Mars, actually, is towards the end of the month. On the 28th, the Mars and the Moon are going to be very, very close together in the evening sky.
Like the Venus and Jupiter conjunction, or not quite so close?
Not quite
right.
so close, but, you know, if you can find the Moon, which is pretty easy, the bright orangey-looking thing next to it is Mars.
Right. And we just missed back in December, didn't we? We actually had an occultation of Mars where the moon passed right in front of Mars, and that was visible from all over East Dorset and all over the UK, in fact. And quite a few of our astronomer friends got up at 5 o'clock in the morning to see that. And you were one of them, Steve.
I was indeed. I even managed to get a photograph of the planet reappearing behind the moon.
Of course, an occultation, we should say, is when the moon passes in front of Mars.
Yeah.
It won't do it this month. It'll be close, but it will not pass in front.
No, and that was good. I managed to get up a little bit too late, so I hadn't actually focused everything up in time to catch it disappearing. But
well, I have to say, I also got up at 5 o'clock in the morning. I'd set up the telescope earlier, but I'd forgotten that where Mars would be at 5 in the morning was right in front of my trees at home, so I didn't see it at all.
Ah, yes.
So, idiot me. Anyway, what about the other planet? What about my favourite? What about Saturn? Can we see Saturn this month, Steve?
I don't know. I haven't looked.
Well, it's actually very difficult to see. It's low down in the early morning sky. Quite tricky to see. But we're coming up through the summer, we're going to be able to see Saturn very, very well. It's going to be higher in the southern sky, I think in the constellation of Aquarius as it comes up. So we'll tell you more about that in future episodes. And then we've got two more planets. We've got Uranus and Neptune. What about Uranus, Steve?
Well, if you want to see Uranus, you're going to need binoculars because it's just below naked eye visibility.
Right.
But the time to look is on the 24th because you're going to have a lovely crescent moon and you're going to have Venus one side of it, where you're going to know Venus, that's the bright one, and the other side of it is going to be Uranus. So it'll be the brightest thing close to the moon, the other side of it from Venus. So
And what does Uranus look like through binoculars?
It looks like a star. It looks like really, it is just a dot in the sky, which is something people don't expect quite often. You know, they think that stars and that should be magnified when you look at them with binoculars or a telescope. And in fact, they're not. If the optics are good, they will actually look smaller, stars will, which is quite anti-intuitive, but that's how it is.
And if you have a bigger telescope, you might be able to have a look at Uranus and see the tiniest of little disks. But really, as Steve was saying there, you shouldn't be too excited. Looking at the planets generally, they have very much smaller disks than you see on those Mount Palomar pictures or in magazines. They really don't look like that in telescopes generally.
The ones that really can be quite rewarding are Jupiter, because you don't need to magnify it that much, and you can see some of the bands on it, and even with small binoculars you can see its moons. You can see the 4 moons that Galileo saw, so you could repeat Galileo's experiment from 400 years ago, 500 years ago.
And what about the stars? How about the stars this month? We've talked about the planets and where we can find them during the month of March. How about that we talk about the constellation of the month? Well, the constellation that we've picked for this month is the zodiac constellation of Leo, which is overhead, Steve, right?
It'll be, well, not quite overhead. It'll be in the south. The zodiac constellations never actually get completely overhead from here in the UK.
That's right.
You have to be pretty far south to be able to get them overhead. But no, it'll be as high as it's going to get in the southern sky.
Yeah, and Leo is one of the original 48 constellations that was described by an astronomer from the 2nd century, a guy called Ptolemy. And he was the first to write down and describe these constellations. And most of them, or a lot of them, don't look anything like what they're meant to be. But Leo, I have to say, when you look at it in the sky, does resemble a lion. And one little part of it, the asterism at the front, as we call it, looks like a backwards question mark.
So you're going to tell us what an asterism is, Mark?
An asterism is a group of stars that form a little pattern that's easily recognisable. Is that good enough? Yeah, I think so.
That's better than good enough. It's excellent.
Yeah. So when you look up in the sky in the south, this is about 10 o'clock to 11 o'clock during the month of March. Right in front of you, you'll see Leo the lion. Now, why is it the lion? Well, apparently, according to Greek legend, this is meant to be the Nemean lion that was eventually killed by that great Greek hero,
Heracles.
Now, some people call him Hercules. Some
that's
people
Latin.
call him Heracles. So we're going to stick with Heracles.
The point of this is that these constellations that we see have inspired humanity for millennia, and it's such a shame that we wipe them out with badly directed light at night.
Yeah.
Because this is a heritage for the whole of humanity.
And this is a topic that we, over the months, will surely cover in more detail. When you go out at night, even here in the New Forest and East Dorset, the chances are that your view of the sky will be impaired slightly by street lights, by security lights pointing up into the sky and ruining your view. And it's such a shame, isn't it?
It is, because it's so simple to deal with. It's the one form of pollution you could literally change at the flick of a switch.
Yeah.
All you have to do is direct lights to where they're actually needed and have them on when they're actually needed, and
that's it.
Problem solved.
Yep.
And everybody benefits except people who sell rubbish lights and people who sell energy.
This is, of course, as you can tell, one of Steve's real topics of interest. There's another bright star, well, there are several bright stars, but the next one that I want to talk about is called Gamma Leonis, which is the third brightest star in Leo. And, of course, we use the Greek alphabet for naming these stars. So the brightest is Alpha, the second brightest is Beta, Gamma, and so on. So Gamma Leonis is the third brightest star, apparently, in Leo. And it is, would you believe, a binary star, which means there are actually two stars. You can only see one with the naked eye, but with binoculars or a small telescope, you can see that Gamma Leonis is a golden yellow binary star.
Do you want to tell us what magnitudes are there, Mark?
Yeah, well, magnitude, that's what astronomers use to classify the brightest stars down to the dimmest. So the brightest stars in the sky are, we say they're 0 magnitude or first magnitude. We can even have a few that are minus. We can go to minus 1.4, which is Sirius, the brightest star in the sky, through 0, then 1, 2, 3, 4, 5. And the faintest stars that we can see with the naked eye are magnitude 6. Now, at home, you probably have a pair of binoculars. If you have a pair of binoculars, let's say 10 by 50s, that's 10x 50 written on them. When you point those in the sky, you might get down to magnitude 9. If you have a small telescope, perhaps a 3-inch or 80mm telescope refractor, you might get down to magnitude 11. But if you had the James Webb Space Telescope in your back garden, now there we go, that's a proper telescope. That telescope is reaching down to minus 30 and minus 35, which is really very, very faint.
Really very faint.
But the stars that we talk about today will be naked eye, that's between 0 and 5 or 6.
Indeed, yes. And if you want to know why the brightest ones have the smallest number for magnitude, it's because the first magnitude stars are the first stars you see as it gets dark and so on. So that's
right.
where that comes from.
Right.
But the James Webb Space Telescope, you actually, believe it or not, you do have access to it. And the same as the Hubble Space Telescope, because they make all the data that these telescopes collect publicly available, so you can download this stuff and you can actually do your own image processing on it. And the same with things like the Juno mission, which is currently at Jupiter. All these things, you actually do have access to it. So if you want to play with real first-class data and get really good images yourself, you can do it. You don't own the data, but you do own the image once you've done it.
Why do stars vary in brightness, Steve? There are so many reasons, but what are the basic reasons that stars get brighter and dimmer as we watch them?
Well, look, as you said, one of them is they puff out carbon into their atmosphere. Now, stars are actually chemical factories. They start off with hydrogen and they combine them to make elements you've heard of, like oxygen and nitrogen and carbon. The bigger stars, the hotter stars, can combine those to make even heavier elements until you get right up to the massive explosive stars like supernovae, where you where you get your heavy metals like gold made.
Right. And what's the other mechanism? Any other?
Well, they can pulsate. They sometimes you have stars in pairs, and the heavier one draws matter away from the other one. There's all manner of reasons that they change. They pulsate in size. They chuck out stuff into their atmospheres.
And don't forget, of course, we have eclipsing binaries, where a bright star is eclipsed by a dimmer star, and the whole thing seems to fade for a few days, a few hours, before returning to brightness. That's
Indeed.
right, isn't it? Back to Leo.
Yes, please.
And then one last thing about Leo we mustn't forget, and that is the famous Leonid meteor shower, which we're not going to see in March, unfortunately. We'll talk about it again probably in November.
November the 17th.
That's the one. And that was one of the famous meteor showers over the past century or so, because every so often, roughly every 33 years, there's an enormous meteor storm, not a shower of meteors, where you see a meteor maybe every minute or every two, but a real storm where when you look in the sky, the meteors are falling like rain. The last one, there was one in 1933, one in 1966, quite a good one in 1999, and we're expecting that in 2032 we should have another storm. But not sure, really, are we? Not sure there'll be another storm.
So what exactly are meteors, Mark?
Well, you imagine as our comet, our ZTF comet, has circled the sun, what it's done in its wake is left tiny little particles of dust, as well as gas and other debris from its passage. And as the Earth circles the sun at certain times of the year, we cross these bands, these trails of dust. And when the dust hits the top of our atmosphere, it very quickly, it's travelling at a very high speed, it hits the atmosphere and burns up within a quarter or half of a second. Now, some of the particles may actually be bigger than dust. They may be sand particles or pebbles or veritable rocks. And the bigger the object when it hits the atmosphere, so the brighter the meteor and the longer it lasts. And even if it's big enough, it may pass through the atmosphere and crash into the Earth. And then it's no longer a meteor, then it becomes a meteorite. That's when it's hit the ground, right?
Okay.
Good. I think we're coming to the end. Before we go, we should definitely say we have within our area here 2 astronomical societies. So if this little show has been of interest, we would really like you to contact your 2 astronomical societies. Stephen and I are members of both.
We are.
One's called the Wessex Astronomical Society, based loosely around the Allendale Centre in Wimborne. And the other one
Is Fordingbridge Astronomers, which started in Fordingbridge just over 10 years ago, but has outgrown it and now actually meets at the Elm Tree in Ringwood.
So we'd love to see you at either society. The websites are, you can find them by your usual Googling, Wessex Astronomical Society and the Fordingbridge Astronomers. And we'd love to see you along there.
Indeed.
We've got lots of help. We're there to help you out and show you the stars whenever we can.
And just to say with that, if you are ever thinking of getting yourself a telescope or anything like that, don't just go out and get one off one of the well-known online box shifters. Instead, come and see us and we can point you in the right direction for good kit that works. And you can even try before you buy, because most of us have stuff that we are only too willing to share.
Yeah. So we look forward to seeing you next month for April Stars, when we're going to talk about buying equipment and how to make the right choices. So from Mark Hardaker
And Steve Tonkin.
we wish you all the best. Clear skies.
And you.